Hello, this is Andrew Becker, and today I will be briefly discussing the anatomy of the skin. So, the integumentary system is comprised of accessory structures like hair, nails, and various exocrine glands, as well as the cutaneous membrane or skin. It's the largest organ in the body, and it's comprised of all four primary tissue types, so epithelial, connective, muscular, and nervous. There's a variety of functions from protecting us from the outside environment to thermoregulation, immunity, excretion, and secretion of things like waste products and sweat, touch as a form of sensation, and even nutrition, since we need sunlight to synthesize vitamin D. The cutaneous membrane is divided into the dermis and the epidermis. The epidermis is the more superficial and is comprised mostly of epithelial cells. It's further subdivided into five sublayers, the deepest of which is the stratum basale. It's a single cell layer thick. This is where all of the germline stem cells are, and they will produce daughter cells that eventually differentiate into keratinocytes and kind of push the skin upwards over the course of a few weeks so that it sloughs off. Also in this region are a number of melanocytes, which produce the pigment melanin, which protects us from UV radiation, as well as Merkel cells, which play a role in our sensation of touch. Superior to this layer is the stratum spinosum. This is where the keratinocytes start to become more specialized. They develop a network of tonofibrils that tightly links them side by side to one another. It also hosts melanocytes as well as Langerhans cells, which are immune cells embedded within the tissue. The next layer up is the stratum granulosum. This is the most superficial layer to contain nucleated cells, and it's where the keratinocytes really start to differentiate. They start producing lots of keratin and keratohyalin, as well as release lipids that kind of form that tough, water-insoluble barrier that makes our skin so protective. Superficial to this, and only found in thick skin, like the palms of our hands or the soles of our feet, is the stratum lucidum. This is a relatively thin layer, and it's kind of glassy in appearance. That's where it gets its name. The most superficial layer, the stratum corneum, is comprised of many layers of dead squamous keratinized cells. So as these cells build up keratin, they do a great job of blocking water from escaping from underneath it, but they also can't get water into and out of their tissues. So the cells naturally die. They spend about 2 weeks on the surface of the skin, and then they get slopped off to be replaced by more cells coming up from underneath them. That takes care of the epidermis. The dermis is comprised mostly of connective tissue and is divided into the more superficial papillary layer, which is mostly loose connective tissue. It hosts the capillary beds that supply the epidermis and is mostly related to anchoring that epidermis in place. It also gives rise to the dermal papillae that create our finger ridges, dermal ridges. And deep to that is the reticular layer, which is more dense, irregular connective tissue. And this is where skin gets its elasticity and toughness from a network of collagen fibers that extend throughout the tissue and also into the papillary layer and even beneath it into the subcutaneous layer. This area is also where the blood vessels come in. They kind of snake through the capillary plexus deep to that layer, work their way up, feeding the accessory structures as well as into the capillary beds and subpapillary plexus that feeds the epidermal layer and the top of the dermis. Deep to that is the subcutaneous or hypodermic area. This is comprised mostly of loose connective tissue, which hosts a lot of adipocytes. So this is where subcutaneous fat comes into play. This fat is important for thermoregulation, shock absorption of the structures beneath it, as well as energy reserves. This is where we metabolize fat from primarily. Clinically, skin has a lot of importance. I like to use it to get kind of a snapshot of a patient's perfusion status. When a patient is kind of verging on shock, they become pale, cool, clammy. And you can tell other conditions as well, like jaundice, indicating liver or pancreatic problems. The skin will actually turn yellow. So I hope you enjoyed this lecture, and I'll see you again for the next one.